let me show you how your book gives you the chart. And this chart can be really confusing. Check it out. If I'm back, oops, I got to get on here. If I back down and I stumble over here, this is the book. This is the chart that comes out of your book. Now, because this only has degrees of freedom that go up to 29, and then it's like, screw it, let's go to Z. That can be a little confusing, okay, in terms of how to read this. Let me show you how to read something. This is a real dummied down T chart. So check it out. What was in on this thing? I forget. I think it was 40. Let me make sure. Yeah, 40. So if I look at this guy, actually, let's put that up because that's sitting right in front of us. All right. These are my degrees of freedom down here on this column. All right. And I'm going to, what am I doing? And I'm going to go down until I get to, I guess it's not going to let me keep that up, until I have 39 degrees of freedom, because remember, degrees of freedom are always n minus 1. Now, let me show you how this works. Notice at the top it says p-values. So p equals 0.05, p equals 0.01, p equals 0.001. Now look down here. What these represent are the critical values that are the t-values that you would get if you wanted p to be less than these values at the top. All right. Now remember, for our problem, we set, where are we? What's going on here? We set our alpha values at 0.05. So the critical value, if the critical value is greater than 2.02, notice that's a little bit different than the one that the book gave us, right? Remember that? That's because this chart is more detailed. I know that for a value of 2.02, I know that the p-value is going to be, if I get a value greater than that, the p-value is going to be less than 0.05. But watch, I can get even fancier. 3.56. Again, let me stumble back here, and what did we get? We got 3.77. 3.56 is actually smaller than 3.77. So what that implies is that our p-value is actually less than, remember, p-value is the probability of getting a value at least as extreme, is less than 0.001. That's a wonderful little tool. So stumble back here is less than 0.001. Since 0.001 is less than 0.05, remember this guy? This was our alpha. This implies reject the null hypothesis. It's that simple. Isn't that cool? There's nothing to it. Wait, we're lagging here. There's nothing to it. That's very cool. All right, let's go ahead and do one more. Let's stick with the theme. Let's go with our vehicles. And what I'm going to do is I'm going to read you pieces of information just a little bit at a time. I'm going to give you all the pertinent statistics. And then I want you to do pause it and try and set this thing up all on your own. Okay? So here it goes. The first thing is, this is the claim. Don't worry about the details, just worry about the claim. Claim is that all cars have a mean greenhouse gas emission of 8 tons. Write your null and your alternative right now. Pause it. Okay, hopefully you paused it. You ready? So we're going to do our null, and we're going to do our alternative. And remember, the null always contains the equality, and it appears that we're talking about our mean is 8, because that was the claim. Claim is mean is 8 tons. I could even write in tons here if I wanted to. So my alternative contains the inequality. I don't know which direction. I could be under, I could be over, I'm not really sure. Okay, so I just say it's not equal to 8. That's easy enough. All right, now here comes the good stuff. We take a sample of 32 different cars. So, woo! Hopefully you're pausing again. Or I guess you don't really have to pause for this. So let's say n equals 32. Now what does that mean in terms of degrees of freedom? Pause and write it down. Degrees of freedom equals 31. All right, this has a mean of, let's see, where's my, I got 7.78. So x bar is 7.78. What is going on here? Sorry about that, you guys. 7.78 tons. And we have a sample standard deviation of 1.08 tons. Now, right now, push pause. That should be tons. Push pause, draw your curve, and figure out what we're doing here. Okay? Go ahead and push pause, draw your curve. Now, notice this is going to be a two-tailed distribution. So I want you to do it however you would like to do it. You're going to push pause. You're going to try it. You can either do it with a confidence interval because it's 2 tails. You could do it with a critical value, or you can do it with a p-score. Okay, I'm going to do all of them, and hopefully you'll try one, and as soon as you pop back, all 3 of them will be completed for you right here. They'll all be worked out. All right, so push pause and go ahead and try. All right, hopefully, bam, they're all up here. Hopefully you went through one, if not all of them. I got to warn you, you are going to have to be proficient in all 3 because I'm going to force you to do them all. Excuse me. All right, first and foremost, real quick, just did a 95% confidence interval. I found that my T sub alpha over 2 was plus or minus 2.040. Plugged it in and booyah. All right, because 8 lives in this interval, that implies that it lives, you remember how confidence intervals work? It lives in the middle 95%. All right, so there's not enough evidence to reject. Don't reject the null, not enough evidence. Critical value, same thing. That's kind of nice that this 2.040 ends up being the same. I used the chart from your book, by the way, that has a little bit more degrees of freedom than the one that I got online. Since negative 1.5 doesn't fall in the critical region, it's not big enough. There's not enough to reject. So thank God I got the same result, right? And then last but not least, this gets really tricky, and we're going to do a bunch of these in class to get you used to it, all right? T equals negative 1.15, which actually implies that there's a p-value greater than 0.1, which comes from the chart. And I'll show you how to read those a whole bunch. Since 0.1 is greater than 0.05 divided by 2, which is 0.025, we do not reject the null hypothesis. So in all 3 cases, we don't reject the null hypothesis. So this, using t-tables, when we have to do this with t's, it's a lot trickier because we got to use the charts. All right, we'll play around with these on our calculators as well, which will give you a nice way to check your work. All right, I hope that was helpful for you, and we'll see you in the next chapter. Bye-bye.